Hi everyone, Miss Butler here. I have a video today on predicting products. So you learned how to balance chemical equations. You learned how to write chemical equations. If I give you the chemical names, you can write the formulas and then balance. We learned the different types of chemical reactions. And now we're going to put all of that together. If I give you the two starting chemicals, can you use what you know based off the types of reactions to predict what the products of the chemical reaction will be? This is just a recap for you on the 5 types of chemical reactions we learned. So synthesis is when we have two different smaller compounds or two different elements coming together to form one compound. Decomposition is the opposite. We start with one compound breaking apart into either two smaller compounds or more typically the elements. Single replacement I call Mr. Steal Your Girl. We have a single element and then some sort of ionic compound. They trade dates, so now A is with C, new couple, and B is an element by itself. Double replacement, we have two ionic compounds that swap partners, so now A is ionically bonded to Y, X to B. And then last is combustion. We have a hydrocarbon, so some number of carbon in a compound with some number of hydrogen reacts with oxygen gas, and the products are always CO2 and H2O. So knowing those types of reactions, you will start to see patterns which will allow us to predict products of a chemical reaction. So this slide is not in the Cornell notes. If you want to just do these 3 examples in the left-hand column somewhere, maybe next to where it says types of reaction summary, for predicting products for synthesis and decomposition, there's not a whole lot I can do as a teacher because there's some different possibilities, but here's the idea. I see in this case the element aluminum and the element oxygen. Oxygen is a diatomic, that's why it's O2. So all I can do here is when I see two single elements, that doesn't really fit the pattern of any other of our reactions. Like single replacement is an element with an ionic compound, right? These are just two elements. So I'm going to assume here that we are doing a synthesis. And all I'm going to do is crisscross the metal and the non-metal. So aluminum on my periodic table is a +3 charge. Oxygen is a -2. When I crisscross, the 2 goes down to aluminum, Al2. The 3 goes to oxygen, O3. And now we can balance. Remember, we always balance last after we crisscross. So in this case, I see that I have 2 oxygens and 3 oxygens. We're going to have to do the least common factor or greatest common factor, whatever it's called. Let's put a 3 here to make 6, a 2 here. That fixes the oxygens, but now we have 4 aluminums on the right, so we need 4 over here. The next one, I see that we're just starting with one compound, so this is going to be a decomposition. And for this class, what we are going to do is we are going to break down to the elements unless I give you a hint otherwise. So in this case, we have water. I'm going to break it into hydrogen. Hydrogen is one of my Hike-Bro-Need Cliff Bars, so we put a little 2. It's a diatomic, and we break it into the element oxygen, which also happens to be one of my Hike-Bro-Need Cliff Bars, so it is a diatomic. We put the 2 there. Now we can balance. I'm going to put a 2 in front of my water to make 2 oxygens, and that means 4 hydrogens on the left. Whoops. So we're going to need 2 right here, so I have 4 hydrogens and then a 1. Okay. For this one, I see a compound again. It looks similar to water, but this is actually hydrogen peroxide, H2O2. This is a decomposition as well, but I would have to give you a hint. So maybe I would tell you for this case. So if I don't give you a hint, you're just going to assume that it's also going to break into hydrogen and oxygen. But I'm going to give you a hint this time that it's going to break into water and oxygen gas. Again, that would be something I would have to write out for you. So now we can balance our equations. I'm going to do a 2 in front and a 2 in front. So now we have 4 oxygens on the left and 4 on the right. The 2 oxygens from here and 2 here is the 4. We have 4 hydrogens, so that would just leave this as a 1. Oops. Okay. Okay, so again, if synthesis and decomposition, because we typically have a lot of options, I am going to say if it's synthesis, you're just going to crisscross the metal with the nonmetal and make an ionic compound. If it's decomposition and I don't say anything, you're going to just break it into the single elements. If it's decomposition like this last one where it breaks into an element and a smaller compound, I will give you a hint to help you figure out what that smaller compound and what that element might be. All right, single replacement, Mr. Steele, your girl. If I notice that I have a single element in an ionic compound, it is likely going to be single replacement. So what I'm going to start by doing is first, I'm going to identify that it's single replacement because I'll see an element by itself and an ionic compound. And then I'm going to look at that single element and see, is that single element under the staircase on the periodic table? Is it a metal? If so, I'm going to replace it with the metal or the positively charged item in the ionic compound. If that single element is above the staircase and it is a nonmetal, then I'm going to replace it with the negative charge or the second thing in the ionic compound. We will then have a new single element based off how I trade, and I need to just check, is that single element a diatomic? So is that single element one of my hike, bro, need, Cliff Bar? If the single element is a diatomic, then when I write it as a single element, I'm going to put a little 2 on it. If the single element is not one of the diatomics, then I leave it. There is no charge, there is no subscript. Then I'm going to look at the new compound, the new couple, and I'm always going to put the positive charge first, followed by the negative charge, and I'm going to crisscross those charges to make sure it's a neutral compound. So let's look at an example. It says we have aluminum plus copper 2 nitrate. So let's first write the reactants. Aluminum. Aluminum is not one of my diatomic elements, so I'm going to leave it as is, no charges, no subscripts. And then we have copper 2. I don't know the charge of copper from my periodic table, but that Roman numeral tells me the charge. And then nitrate 888, that tells me it's on my purple polyatomic list or the back of my periodic table. That is NO3 with a -1 charge. And now we can crisscross. The 1 goes down to copper, so we get Cu1. We don't usually write the 1, but you can. Protect your polyatomic NO3 in parentheses, and this 2 goes outside of the parentheses. So aluminum plus copper 2 nitrate, there are my reactants. I know this is single replacement because I see an element by itself and then a ionic compound. And so now we're going to go through the steps. Look at the single element. Aluminum is under the staircase. It's a metal, which means it's going to trade places with the metal, the copper, the element that's also under the staircase or the positive charge item in the compound. When we trade those, what that'll mean copper is all by itself without a date. So when we have our element by itself, we need to just check, is that new single element one of my hike bro need Cliff Bars? No, it is not, so we just leave it. I know it was copper 2 over here, but now that it's just copper by itself, we don't put any charges or subscripts. The only time we put a subscript on a single element is if it's one of our diatomics. So now we have a new compound. Aluminum is going to date nitrate. Aluminum on my periodic table is a +3 charge. Nitrate is still NO3 with a -1. When I crisscross, the 1 goes to aluminum, Al1. The NO3 stays in parentheses, and the 3 goes on the outside. Now that we've crisscrossed everything, we are going to balance. So I see 2 nitrates, 3 nitrates. Let's make this 3 and 2 so that I have 6 nitrates. That gives me 3 coppers on this side, so I need a 3 over here. 2 aluminums on this side, so I need a 2, and we are balanced. All right, for double replacement, we know it's going to be a double replacement because we're going to see 2 ionic compounds reacting together. Here's what I like to do. I look for what element or polyatomic are the negative charges in each ionic compound. Those are always going to be the second items. I'm going to swap those second items in the compound to make 2 new couples or 2 new ionic compounds. We need to make sure, just like we did with single replacement, that the new ionic compound is neutral, meaning we are going to crisscross. So my first example, I have sodium chloride. Sodium is a +1 from the periodic table. Chloride is regular chlorine, which is -1. When I crisscross, those cancel out, so I get NaCl plus We have beryllium, which is Be with a +2, and hydroxide, even though that ends with "ide," it's one of my sneaky polyatomics on the back of my periodic table or my purple sheet. That is actually a polyatomic, even though it ends with "ide." It's capital OH with a -1. So when we crisscross, we get Be1, OH, protected in parentheses, and the 2 goes outside of the parentheses. All right, so I have my 2 compounds. Now we do our reacts arrow, and we're ready to predict the products. Well, the negative charge in each is chlorine and hydroxide, so those are the ones that we are going to swap. That means my first new compound is going to be sodium. We always put the positive thing first, crisscrossed with hydroxide. So I still use the sodium from the periodic table is +1, hydroxide on my purple sheet is -1, and those are just going to cancel each other out. So we get NaOH plus new compound. So the only ones we have left over are beryllium, and so remember we always do the positive first. So I'm going to get Be +2. The +2 comes from the periodic table, and the chloride Cl -1. When I crisscross, we get Be1, Cl2. So there's our 2 new ionic compounds. Notice we did not just take, oh, there's 2 on hydroxide, put a 2 here. When we make a new ionic compound, they have to crisscross, get to know each other, when we make the new compounds. We don't just take our baggage from our old relationship. All right, I see 2 hydroxides, so I'm going to put a big 2 here. That makes 2 Na, so I put a 2 here, 2 chlorines, that matches, so we are good. 2, 1, 2, 1. All right, combustion is my favorite to balance to predict, as long as you can know that it's a combustion. So I'm always looking for a hydrocarbon, and that's the tricky part because these X and Y's can be any numbers. I'm looking for a carbon bonded to a hydrogen, any amount of carbon, any amount of hydrogen, plus O2 gas. So I know it looks like a compound and an element, but it's not an ionic compound because it's 2 nonmetals. So really you're looking for that hydrocarbon plus O2, and if we know then that that's going to be combustion, the products are always CO2 and H2O. So here's my favorite example. Some number of carbon stuck to some number of hydrogen, oxygen gas, O2. My products then are always CO2 plus H2O, or H2O plus CO2. The order does not matter. This one is a little trickier to balance, so I'm going to give you a hint. I'm going to put a 2 in front here, so that 2 cannot change. That means I have 8 carbons, which requires me to put an 8 here. That means on the left side here, I have 20 hydrogens, so I need to put a 10 here. If we add up the oxygens, I have 16 O's plus 10, that's 26, so we're going to need to put a big old 13 in front of that oxygen. That was a tough one to balance, but easy to predict, CO2 and H2O. All right, let's practice these together. We have solutions. That just means it's aqueous, so I'm not worried about that. Potassium sulfate. Okay, I don't see any nonmetals. I don't see prefixes, so that means we're going to have to crisscross. So let's take care of that. Potassium is +1. Sulfate 8 is on my polyatomic sheet, SO4 with a -2. So I get K2SO4. And barium nitrate, also no prefixes, so we're going to crisscross. Barium on my periodic table is +2. Nitrate 8 is a polyatomic, NO3 -1. Get that from the back of my periodic table. When I crisscross, I get Ba1, NO3 in parentheses, and 2, because this 2 goes outside the parentheses. The 1 went to barium. All right. Those are my 2 reactants. We first have to decide what type this is. I had to crisscross for 2 ionic compounds. The only one we've seen so far that has 2 couples or 2 ionic compounds is called double replacement. So we are going to swap dates and make 2 new couples. So I know we're going to swap dates and make 2 new couples because when we start with 2 ionic compounds, it has to be double replacement. The negative and the negative are the ones that are going to swap dates. So nitrate is going to swap with sulfate. Okay, so that means K, because we always put the positive thing first, K is +1, is going to trade with NO3 -1. And again, this charge comes from the periodic table. This comes from my polyatomic ion list. When I crisscross, I get I get an eraser. K1 from there, NO3, and you can put the 1, I don't usually, but I will today, plus, and our new compound is the leftovers. We haven't used barium yet. Positive thing goes first, so barium first. It's 2 plus from the periodic table with the sulfate. SO4 always has a -2. When we have a +2 with a -2, we know they just cancel, so I just get BA and then in parentheses SO4. The 2's canceled each other out. So there's our 2 new compounds that we crisscrossed. Now we're ready to balance. You can get a whiteboard and take inventory, but I see 2 nitrates on this side, so I need 2 over here. That makes 2K, which actually is what I already have. So this is just 1, 1, 2, 1. All right, zinc metal is added to a solution of sulfuric acid. So we have zinc. That is just an element. I have to check my list. Is zinc one of my Hike-Bro-Need Cliff Bars? No, it is not, so we don't put any charges or numbers. And it's mixed with sulfuric acid. I love when Miss Beller just gives me the formula. Sulfuric acid has the formula H2SO4. I'm going to put the SO4 in parentheses. Okay. You will learn about naming and writing formulas for acids in our acid base unit. So I will always give you those formulas in parentheses after the name. All right, here's what I see. I see an element and I see an ionic compound, right? Something positive, hydrogen, with something negative. So we know we're going to trade dates. How do I know who zinc will trade with? Well, zinc is a metal, a positive charge thing. It's going to trade with the positive charge position, right? If I make really small, H is +1, SO4 is -2. Zinc is normally a positive, so it's going to trade places. It's actually a +2. You should have written that on your periodic table. So it's going to trade places with the positive item. What that means is hydrogen is my new element without a date. Look at your single element. Is hydrogen one of my Hike-Bro-Need Cliff Bars? Yes, he is, so we put a little 2. Remember, we only put a subscript on single elements if it is one of my diatomic Hike-Bro-Need Cliff Bars. So now I'm ready to crisscross the new couple. Zinc is a +2. If you don't have that written on zinc on your periodic table, you should do that. Zinc is always +2. And then sulfate is SO4, and from my polyatomic list, we know it's -2. A +2 and a -2 cancel, so we get ZnSO4. And now we're ready to balance. And actually, I think this one is even Stevens already, so we'll just put 1s. Last one, dicarbon hexahydride. I see prefixes, so we got no crisscross. We're just going to use the prefixes. Di means 2, so we get C2. Hexa is 6. Hydride is hydrogen, so H6 reacts with oxygen. Oxygen is one of my diatomics, so we call it oxygen, but it's really O2, Hike-Bro-Need Cliff Bar. And so here's what I see. Oh, sorry, this one was double replacement. I see a hydrocarbon reacting with O2 gas. That must be a combustion. The products for combustion are always going to be CO2 plus H2O. So now I'm ready to balance. We need 2 carbons. We have 6 hydrogen, so we put a 3 there. And on this side, I have 4 oxygens plus 3, that's 7 oxygens. So this is where I have everything good, but O is odd, so everything balances except for my O's. I have an odd number, I need an even number, so let's double everything. I'm going to put a 2, this is going to be a 4, this is going to be a 6. Now on this side, I have 4 times 2, 8, plus 6, I have 14 oxygen, so we put a 7. So 2, 7, 4, 6 is the correct balancing for this combustion. All right, here are those one more time. We just saw those. It's a little neater, though, if you if you missed anything. All right, for these problems, it says table practice problems. So I want you to pause the video, find someone in the class that is in the same spot as you, and you're going to work on these 3 together, and then you will unpause the video and check your answers. So don't peek. Answers are coming after you pause the video, but they're popping up in 5, 4, 3, 2, 1. All right, here we go. So I know this one, don't worry about the big numbers yet, is single replacement because I have a compound and a single element. The single element is a metal, so it's going to change with the first position or the metal in the compound. So that means K will be by itself. It is not a diatomic, so no charges, no little subscripts. Okay, my new compound is going to be magnesium with chlorine, but we have a new couple, so we got to get to know each other. We crisscross. Magnesium's charge is 2 on the periodic table, chlorine's is 1, so I get MgCl2. These big numbers came from balancing after I had written both of these perfectly. Okay, and so again, this is Mr. Steal Your Girl. I knew that because we had a compound and a single element. All right, a piece of iron is added to a solution of mercury 1 nitrate. So I have my iron. Iron is not a diatomic, so no numbers. Okay, and it's added to mercury 1 nitrate. So I'm going to crisscross mercury with a +1. Nitrate is my polyatomic -1. I protect that in parentheses. That's where this blue HgNO3 comes from. I know iron is a metal at room temperature, or sorry, it's a metal, so it's a solid at room temperature. And then this, they told me it was a solution, so I put aqueous. You don't have to do that on these. I'm just getting you in habit for it. Okay, and then it says, hint, iron will form +2 ions. Here's why. Iron's a metal, mercury's a metal. Those are going to trade. So when I crisscross, I need to know the charge of iron. It's not on the periodic table. So they're telling me it'll be a +2. And I crisscross that with the nitrate, which is always -1. That's how I got this Fe1NO3 2 outside the parentheses for the 2. And then I'm left with mercury, sad without a date. Mercury is not one of my Hike-Brony Cliff Bars, so no numbers on that. Okay, these big coefficients from the single replacement are from balancing. Lastly, carbon tetrahydride. So no prefix on carbon, just 1. Tetra is 4, so 4 hydrogens. No crisscrossing, we just use the prefixes. Reacts with oxygen. Oxygen is one of my Hike-Brony Cliff Bars, so it gets an O2. I see a hydrocarbon plus oxygen. That's always a combustion. Products are CO2 and H2O, and then you can balance. All right, last 3, this is individual. So you are going to work solo on these. Pause the video, try all 3 of these, and then when you have your answers, I want you to play the video again and check your work. All right, it is single replacement, that's a hint. So we have sodium metal, here's sodium by itself. It's not a diatomic, so no charges, no subscripts, just regular sodium. And it's reacting with aluminum nitrate. So I find aluminum on my periodic table, nitrate on my polyatomic. When I crisscross, I get Al1, in parentheses NO3, outside the parentheses 3. It's single replacement, so sodium is a metal. It's going to trade with the metal in the compound. That leaves aluminum all by itself. Aluminum is not one of my Hike-Brony Cliff Bars, so no numbers, no subscripts. And then my new compound is going to be Na crisscrossed with the nitrate. 1 and 1 cancel, so just NaNO3. When I balance, I get 3, 1, 3, 1. You can put 1s or leave these blank. Label the type of reaction. So I have small pieces making one compound, that's synthesis. I have an element with an ionic compound, a new element with a new compound, that's Mr. Steal Your Girl, single replacement. I have a hydrocarbon, some number of carbon bonded to some number of hydrogen with oxygen making CO2 and H2O. That is always combustion. Okay, complete the double replacement. So I see 2 ionic compounds. They also told me it's double replacement. So we are going to trade dates. You can either have the 2 positive things swap or the 2 negatives. It doesn't matter. But what I know is K is going to be with nitrate. Magnesium is going to be with PO4. Notice it's positive, negative, positive, negative. That's how I decide the order. Okay, crisscross, potassium with nitrate. Charge from the periodic table. Charge from the polyatomic list. They cancel out, so I get KNO3. Magnesium is +2 from the periodic table. Phosphate is PO4 -3 from my polyatomic list. 3 goes to magnesium. The 2 goes down outside the parentheses. Now we're ready to balance. So in order to get 2 phosphates, I needed a 2 here. You could put that phosphate in parentheses if you want. And so that would be 6 Ks. We put a 6 here. That gives me 6 nitrates. So I need a 3 to multiply by 2. And now we are balanced. All right, your other assignment is this practice worksheet. So it says to read each section. So here's some notes just to refresh your memory and some example problems. And then you're going to do the practice. Then same for single replacement. Read the notes. And here's some examples, and then you're going to do the practice. Okay, synthesis and decomposition, you're going to read the notes and then do the practice. Remember, I had to keep these really simple, so you're just making a compound for those. And then here's mixed worksheet. I don't tell you what type. Oh, sorry, I lied. These are decomposition, so you'll just break it into the elements, keep it simple. Here's some notes on combustion and some practice for you, and then these practice ones are all mixed together. So tell me what type of reaction based off what you're given to start, right? 2 ionic compounds. We got to crisscross trade dates. That's double replacement. And then you'll write the products and balance the equation. This is something you're going to be working on the rest of this week.